This is an introduction to orbital diagrams. On the left, we have an energy level diagram showing the subshells and the orbitals within the subshells in terms of increasing energy as we go upward. And on the right, we have a periodic table for reference. And orbital diagrams are essentially electron configurations, but they show a little more information. We use a box to represent each orbital, and then we use half arrows to represent each electron. And a half arrow pointing up corresponds to an electron with plus 1/2 spin or up spin, and a half arrow pointing down corresponds to an electron with down spin or negative 1/2 spin. So let's see how this works. We'll start with lithium as an example. And lithium has the electron configuration 1s2, 2s1. And how the electrons will fill into the subshells for lithium, they start in the lowest energy, and then we can have up to 2 electrons per orbital. So the first electron goes into the 1s orbital, and the second electron also goes into the 1s orbital, but with opposite spin. Now that orbital is filled, so the third electron goes into the 2s orbital, the 2s subshell. That's it for lithium. And so how we write the orbital diagram is essentially what we have already on the left, but we write the orbitals horizontally in terms of increasing energy from left to right. So like that. 1s, then 2s, then the 2p subshell with 3 orbitals within that subshell. And then we just fill in the electrons showing their spin states as we did on the left. And that is the orbital diagram for lithium. All right, let's try carbon next. Carbon has an electron configuration 1s2, 2s2, 2p2. And we'll fill in the electrons from lowest to highest energy following the rules as before. First 2 electrons go in the 1s subshell. Second 2 electrons go in the 2s subshell. Each of these are only 1 orbital per subshell. And now we have 2 more electrons that go into the 2p subshell. There's 1. And then the next one goes into a separate orbital. And we have 2 what are called unpaired electrons in separate orbitals, and the electrons fill in with the same spin direction so long as they are in separate orbitals and unpaired. That's it. We've filled in the electrons into the orbital boxes, and now we'll write our orbital notation by simply just doing this horizontally. 1s2, 2s2, 2p2, and notice we show a little more information because it shows clearly that the 2 electrons in the 2p subshell are in separate orbitals with the same spin states. All right, let's try chlorine next. And chlorine has an electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. And remember, once we start getting to longer electron configurations, it's often simpler and convenient to use an abbreviated or condensed electron configuration. So instead of writing out 1s2, 2s2, 2p6, we represent those inner shell or core electrons by the neon symbol in brackets. And we'll do this with orbital diagrams as well. So the electrons now are going to fill in 1s2, 2s2, 2p6. That corresponds to neon, so we'll use this condensed notation. And now we'll write out explicitly the electrons in the outer shell. So in this case, it'll be 3s1, 3s2, 3p1, 2, 3 in separate orbitals with the same spin state. And then 3p4 and 3p5 now have to start pairing up. So we end up with 1 unpaired electron in the 3p subshell. We have 4 paired up electrons in the 3p subshell. And we write our orbital diagram as we've done before. Neon in brackets represents those filled inner shells. And then we fill in the subshells in the outer shell with boxes representing orbitals and half arrows representing electrons. All right, here's our last example, iron. Iron has a condensed electron configuration of argon, 4s2, 3d6. So we'll do the same thing as before, all of that stuff, 1s2, 2s2, 2p6, 3s2, 3p6 is the argon noble gas arrangement, noble gas configuration. And now we have 8 more electrons that are in the 4s and 3d subshells. The 4s subshell fills first, 1, 2. And then the 3d subshell is slightly higher in energy than the 4s subshell, so it fills in next, 1, 2, 3, 4, 5. We have 5 orbitals in the 3d subshell, and then we have each electron in a separate orbital as long as possible with the same spin state. And since this has a 6th electron in the d subshell, that has to pair up. And so we have 4 unpaired electrons in the 3d subshell, and our condensed orbital diagram is argon, 4s2, 3d6, and we're explicitly showing the electrons, which orbitals they're in, and their spin states. And that's it for an introduction to orbital diagrams.